see it now? Okay, thank you. Okay, so it's really how you sample. So basically, you have your data, you have your model. There's an interaction between them, and now you can imagine that if you really have a limited budget on what to annotate in your data, right? How can you pick the samples that will get you basically the best mileage out of your model, right? That's basically what the idea is in active learning. So we'll spend a couple of lectures there, maybe 1.5. And then we'll talk about uncertainty and anomaly detection. These are kind of the last two topics. So the boundaries between the lectures are a little bit fluid, depends on how much we can cover in each one of these subjects. Also, I'm hoping to get some people from my lab to talk about some of these. So for example, for explainability, if I can get my postdoc Mohit, who's really an expert in explainability, if he can really give at least one of those lectures or both of them, that would be really great. Yes. Can you wait until I finish let's talk about the announcement? Yeah, thank you. Any questions about the topics? Is there any other topic that you would like to see? Basically, can you explain why your model gave you this outcome, right? Can you basically, you can think of it as if there is a healthcare provider, right, and using an AI model, right, and then it gave them some kind of an output. Can they have a tool, basically an interface, without them knowing anything about math or machine learning? Can you explain to them why the model gave them this kind of classification or this regression or whatever the application is? Yes. Can you speak louder? Retention? What do you mean by that? Oh, very good. That's basically when I talk about a little bit of active learning, a little bit of uncertainty. If I can get Ryan Benkert from my lab, that's his thesis topic, basically forgetting events, how you switch between forgetting events. I will see if he can talk a little bit about that. But yeah, we have a couple of papers in there. It's very, very fascinating, basically, if you keep track of that. Okay, so that's a good suggestion. Okay, I will come now back to the right column, but before I get there, I want to just go through some announcement of the final exam that I just posted. Okay, so the final exam, if you look at the registrar's matrix, is April 28th at 8 o'clock in the morning. That's 8 to 11:50 in the morning. For us, it will be a take-home exam. So it will be assigned the 21st. That's a Friday, and then it will be due the following Friday. That's April 28th at noon. That will be the take-home exam. Now, if you look at the project, I'm making some changes for deliverables. Before we had a term paper due on April 14th. Now it will be due April 21st. So there's a 1 week extra. I think quite a few teams will appreciate that. But also for the presentation, I figured that basically you can really record a 5-minute presentation about your paper, than just presenting it in here. So this way we can use 2 lectures to lecture you about some topics. Now, the downside, if there's a downside, you have to include in your report basically the link to your recording of the presentation, so that the 21st you are done with the project. Does this make sense for the graduate students? Yes. Right.
Are we going to be able to know what like the outcomes for this project are? Like what type of accuracy you're expecting or something like that?
Not necessarily the accuracy as much as I really want to see basically how can you analyze what's really happening. That's really important for me. If you just plug and play and it's okay, here's what's really happening, and without me witnessing you going back, changing certain data, looking at inputting a data in an inference stage, and have an analysis of what's really happening there. That's basically what I'm looking for. That's basically where I see that's really worthy. More than the accuracy has to be a certain, it's not like 10%. Like it has to be a reasonable number. But if you can provide quite a bit of analysis, that's where I'm looking at. For example, if you're using a pre-trained model in one algorithm and another one you are training from scratch, and then how can you compare these? Like you make more effort to compare them, not necessarily but only accuracy-wise, but also more analysis-wise. Like, you have the same input for both, and you're getting this kind of output. You have the gradients happening this way. You can analyze the difference between them. That's what I'm looking for. So it's really more about just not just plug and play or accuracy only.
Yeah, I guess there's only 3 classes, so if they were
First of all, it's imbalanced data set. It's really imbalanced. It's a very tricky one. It is very imbalanced. That's why the accuracy will be very misleading, right? Very misleading. That's why we're asking for the link to your code, right? We are looking at that as well. Because I can imagine some people may hopefully not, but they may play that trick, right? We have kind of an idea how the performance for these different networks should look like. Kind of rough idea. So if somebody bring us numbers that's off the chart, we will know there's something not right. We'll go to the code. Okay, so no, not now, not now. But hopefully there will be a paper we submitted. It will have all that. It's a benchmark paper. I think there will be 4 problems there. Four problems, but they are really hands-on 4 problems. So I would say from an average student, a day should be more than enough, like 8 to 10 hours. Yeah, 8 to 10 hours for a student. Yes. It's same as a homework format. Same as the homework format. Yes. Same as a homework format. There will be a Kaggle competition as well. It was fun for some. So. Wow, you like your classmates. Okay, I understand. Okay, on the right-hand side, you can opt out from the final exam if you choose to do so. So you have until April 12th to say, I don't want to take the final exam. If you are a graduate student, then you have to say, but that means you are counting, we can count your project grade to be your final grade as well. Right? If you are an undergraduate student, that means you are taking your exam 1, exam 2 average as your final grade average. Oh yeah. Unless you have a very, serious doubt about the grading and you ask for a regrade, then we will look into it. Other than that, it's fixed. We will look at that at the end of the lecture today. Yes. Hopefully that's the plan. Yes, that's the plan. So you will have the first 6 homeworks. The only missing one will be homework 7, and then the final exam. But your exam 1 and exam 2 is already, the grades are out there, and I'll give you the exam paper today and go through the solution today. So you will have everything about exams today. But by April 12th, please go to this link, and then you're asking about the link. This is the link basically just to opt out. If you don't fill out the form, then I will assume that you will take the final exam. So if you don't fill the other form and you don't take the final exam, your final exam grade will be 0. Does that make sense? Yes. Bonus. Yeah. We are looking into homework 7 to add 1 about autoencoders, but if I can simplify it, I will add it as a bonus. It's really tough one. If I can simplify it, I will add it as a bonus. In homework 7, yes. That's what I start with. So that's a good question. It's very important because I will receive a lot of questions about this in private message on Piazza. So if I will you will look at how I see the grades in this 3 sections. We have the undergrad, the graduate, and the QF sections. So we have 3 different sections. I look at them separately as well as together. And the reason is when I say curve, right, I look at the boundaries, and I also look at the students who are really around the boundaries. And usually I pump people up, not down. So, and I always see an advantage in looking at different sections because that means more people will be pumped up to the next grade, to the higher grade. So that's how I look. So it's not, I don't think in this course will be 91 to, I think it will be lower than that. In past semesters, the last 2 semesters, the first one was a little bit small number of students. It was more in the mid 80s between A and B, I think 84, something like that, 83, something like that, between A and B. I don't promise they'll be the same here because we have much better students now this year. Yes. Wow. Some people have doubts. Yes.
Do you have like an estimate as to when those down?
After the 28th, yeah, I have to look at the final exam, and then after that, I'll have a whole Excel sheet, and then I will just go through those. Any other question? Okay. So now if you go back to, sorry. Yes, I'm having them with me now. Yeah, I will have them with me, and then I'll see either Salim will take them with him tomorrow to his office hours, or I will have them back with me on Wednesday. So, but I will have them here. I'll give it to you in like half an hour. Okay, so now look at the right column in this canvas. Okay, so homework 6 is due on April 7th. So you have literally 3 weeks for homework 6, right? But it's not like a as a 3-week homework as well. I just counted the spring break, right? So it's that's the reason why we have 3 weeks. And then April 12, we have this form that you have to fill out if you want to opt out from the final exam. If you don't want to opt out from the final exam and you want to take the final exam, you don't have to fill this form. Okay. Does this answer your question?
Yeah.
Yes.
Is there also no Wednesday lecture for or is it just
Oh no, we have a lecture. Why not?
oh this didn't say
No, we have a lecture. Yeah. And then the April 21st is really very busy, especially for the graduate students, because you have homework 7 is due, and you have the project is due, and then you have the final exam is released. So April 21st is kind of a very, very busy. So please plan accordingly, especially the graduate students. That's a very, very, very busy week. That's only for one course. So I know you have other courses. Okay, any question about the deadlines we have on the right-hand side? Yes. It's today at 11 a.m. or 12 p.m. Yes. I think 11 or 12. Yeah. Okay. Another question about this this timeline? Okay. Any question about these options, project and the final exam? Yes. No, we have homework 7. We have one more homework. Yes. Yes. No. It's worth asking, but the answer is no. Okay. So for the next half an hour or so, I'll just go through. There's really more of there's another. Let's see why this one is not working. Okay. Okay. So what are the different strategies that you do? And really more of really kind of, I was always saying babysitting the CNN or the neural network. What are the different things you have to look at? You have to, and these things come with practice. The more you really deal with them hands-on, the more you start to be very knowledgeable about them. And among the very senior hands-on students I have in my lab, it's really amazing just to listen to when they discuss these things, because they spend hundreds, if not thousands of hours just with these networks. So hopefully I'll just give you some kind of things that are very common out there, and some of them are from my own students as well. Just it's not necessarily you will have to use them in homeworks or the project, but it's good to know about these different tactics. So what are the different architecture? There is really no specific answer. There are some backbone architecture that people really know, and we looked at some of them. If you want something very quickly and just run with it, AlexNet is like kind of a very primitive performance-wise, but it's very quickly to just get something up and running. ResNet has been really quite a bit out there. People use it as backbone, but there's no really very specific network. But with time, you'll see some survey papers saying about if you have this kind of criteria in your application, then these are the backbone application that you have to use. So just look at GitHub. That will be the best resource to really figure out for your application what will be the best architecture or backbone that you want to use in here. So, and also what's really applications, classification and segmentation and prediction. All these are very different. Done. And I can tell that you are very resourceful when it comes to online resources. And I will talk about online when I talk about the exam too, because it's a very interesting experiment. Okay, what are the different architecture? Definitely, it depends on what you are looking for. Depends on the data that you are looking at, how far you want to go, like how deep the network is. And then usually people really have quite a bit of trial and error. There's quite a bit of really trial and error in this domain. And honestly, your application is really a very good fit to something that's already trained out there, right? If it's not, then you spend a lot of time basically trying different things, figuring different strategies to really come up with what will be the best pooling, what will be the best activation function. Is dropout helping me or not? And then if it's not helping me, then why? And all of these basic questions you keep asking yourself. But it's my advice is really very, very important. A big mistake in my lab, like junior students do, they take whatever the model is giving them and whatever conclusion they say, okay, here it is, right? But it's very, very important to go and ask yourself, like ask questions. Why if I do this dropout, like to go to the extreme, like have some engineering sense of it. Like how many we have a computer scientist in here? Okay, don't be a computer scientist, be an engineer, right? Just look at the, no, seriously, that's where it's very, very important to really kind of, stress test your model, right? You have to stress test the model. Put something that you know exactly how the model should react, right? Something very extreme and see basically what happens. If it doesn't give you what you're expecting, there is something wrong with your implementation. That's the straight answer, right? So this is very, very important. Like have a very, as in the exam, like have a very meaningless activation function, right? And see basically doesn't really give you what you are expecting or not, the wrong answer that you are expecting, right? So these are the things I think I all emphasize on my junior students to really spend more time on making mistakes, intentional mistakes, than just overcoming basically something they haven't paid attention to. We will spend more time on this on Wednesday, the autoencoder, and you have your homework 6 is already talking about this. Where you have an encoder decoder, and in that case, basically you are reconstructing. So you have an input image or an input signal. It can be one dimension, it can be multimodal as well. And then you are reconstruct that signal in here using this kind of an encoder decoder kind of structure. And we'll talk more about this here. But this is kind of more of a dense prediction problem, not a classification problem. But I will spend more on this one on Wednesday in here. Basically, the loss function, what are the typical loss functions? For example, if you look at just simple classification as your project, then the cross entropy has proven to be really kind of the de facto, right? People really use that as the loss function. If you are looking at things that have to do with kind of denoising problems, then anything like about mean square error L1 could be a good alternative to cross entropy as your loss function. So these are different, yeah. If you have a signal and then you with a set resolution, either it's speech or doesn't matter what it is, right? And you want to add basically have it higher resolution. You can think of a video, right? You have a 720, you want to make it 1080, right? You add more upsampling. Yes, it's upsampling with the filtering, not the classical signal processing way. But now with the machine learning network and your network, it's you are really using generative component to add these new samples, right? And now how you decide which loss function, then basically kind of the anything with the error like L1, L2 would do. No, I'm opted out from it last year. It's if I want to really cover GANs in a meaningful way, then I'll take at least maybe 3 lectures, 3 or 4. That's quite a bit. Yes, if I want to spend time. So I opted to the other topic that I just mentioned because with those 3 or 4 lectures, you have 2 other topics that you can be aware of, and they are really based on the neural network. But yeah, I mean, I'll see in the RNNs, maybe I will just touch base on the GANs, but I'm not sure. But I'll see if I include maybe 15 minutes on it. Okay. When you have an imbalance, as in the project for the graduate students, you have an imbalanced data, then you have to be very careful about that, right? Because that can be very, very misleading. And I already see some of you already have experienced that with the project. So here is basically kind of something from the geophysics side of things, where you have, this is subsurface volume. You can see this subsurface. Each pixel in this volume, or each voxel in this volume, is like 25 by 25 kilometer area, and depth, I think 9 meters. I'm not sure about the depth resolution. And then you have these faults, basically they are looking at, the geophysicists are really looking at. And now when you have this multimodal kind of data you are looking at, then the seismic one here, this whole volume, which is 150 to 150 kilometer by 700 kilometers or so. And then you are really looking for different classes, but if you look at just the fault classes, this is really, really very sparse. I mean, it's even if you have annotations, these are not even 0.05% of the whole volume. I mean, these if you just count the number of pixels in these faults, because these are just 1 pixels a line for 9 kilometers depth. So imbalance in here become a very, very extreme in medical data. We have a very similar issue, right? Because when you have tumors, stuff like this, these are usually very, very small percentage of your data, right? So that's this a very common problem outside computer vision, right? In computer vision, we don't really have a problem because you have dogs and cats and cars and all this. That's the easy stuff. But when you go to more computed data like medical imaging or any scientific imaging, then becomes an issue. Even in the geophysics, for example, we have one-dimensional data, which you can think of them as the biomarker in medical, or they can be a speech signal, like one-dimensional signals. And even that, the phenomena that you're looking for are very, very, very sparse, like extremely sparse. So even if you have annotation, it's really an imbalanced data set that you are really dealing with in here. So one trick that is very, very common trick, that's not only the only trick, but is a very common trick, is really kind of to change your cross entropy loss to have a weight, right? So the weight in here, so for every different class, you have a weighting function here, and the weighting function is really a function of how the frequency of that class, right? So that's basically your weighted cross entropy, and definitely with this will give you a little bit of an improvement in what you are really getting. Improvement not necessarily in terms of higher accuracy, because it lower it, but it's more truthful accuracy, right? It's more accurate representation of how good your model is compared to the other. Yes.
How does this compare to just like normalizing the data, like the training set, like just making the wall class 30 evenly?
How would you do that if you don't have access to generating new data? Like, oh, you change the training set, you mean? Oh, you change the training set? Yeah. So what happens? So you get rid of the extra ones in the... Yeah, but in that case, how do you decide, basically back to the active learning, the sampling, how do you decide which one of those you will keep, right? There's problem for active learning, right? It's as if, how do you sample those? In that case, see, you have a resource, which is the training set, right? And you have annotation for them, and you're not using them, right? So that's where the downside of it, right? But if you have a sampling strategy, and that sampling strategy tells you, for one class you have 200 samples, another class you have 200 samples, and you have 1,000 for the third class, right? And then when I pick only 200 of them, if you can have an active learning model to tell you which ones are really the most reasonable ones that will affect your model, that will be amazing. That will be a very nice way to do it. I would like that. Yes. How does it compare to this? I don't know. How does it compare to this? I don't know. Because this is also is really more or less an ad hoc. Like it's really kind of as we are really dealing with all the classes, right? As if they are really within uniform, right? They are the same weight. They have same, but in the feature space they are not, right? Some of the classes will map into the feature space in a very different manner than the other class, right? But in here we're making it as uniform, right? And that's basically also a problem with this one. There is another one which is called the focal loss, right? The focal loss in here that the focal loss is really kind of we bring this parameter here, and basically you're really saying I wanna emphasize the least important ones and the very common ones. I want to de-emphasize them. But that's what you're really doing. So you have um, uh, this is the cross entropy. All what you're doing this basically term in here, and then this parameter becomes a hyperparameter that really controls how much you want to suppress your common class, right? Or the most common one, because the problem you have one or two classes that are really overwhelming everybody else, right? And that's really very common in all the computed imaging, like medical data as well. So this actually this one I know for sure it gives you quite a bit. It's quite a bit of control over that. And then once you start doing this, then you start to know basically you have your confusion matrix, and you start to know basically how much because you don't want to de-emphasize the common class as much that much. You want to be very careful about that, right? So the focal loss would be between this one and this one. This one is much more effective. The focal loss one. So in the project, I would recommend trying just the typical one, cross entropy, and then trying this one, the focal loss. I think it will add quite a bit of value to your experience and the project. But yeah, the sampling one, I'm thinking about it. I think there's a usually we take any annotated data, we take it, right? We don't want to throw it away. However, you bring really a very important aspect that not all data is really good. It's some annotation, they have some uncertainty in them or some errors. Can you have a sampling strategy to say it will help you to get rid of those samples as well as help you with the imbalanced data training?
Yeah, I noticed that those frames don't have anything. They're meaningless. Only a couple frames have patient action.
Yes. That's where it's very, very tough data. No. Usually what happens, and this is something variable because these are what they did, they look at the center one. And if you take the volume, look at the central one, where basically it's going with the cross section of the retina. You look at those, and usually they're not exactly the same slide in every single patient. They can be one or two off to the right and the left, right? But they are within that region. So they start from there and then they go outward. And as they go outward, they will just say there's nothing to worry about there from a clinical perspective. The volume, yes, that's where basically the kind of what's the most of the actions happening in the retina. Yes, that's
for the project. Are we expecting to be able to annotate every frame you give us, or can we take all of them and process it by ignoring the first pass or second?
It's as if it's an open-ended kind of project. So whatever you see, it's really fit.
We're not expected to be able to say, here's frame number 0, what classes it's falling into?
For the inference, yes. I mean, the inference you have to do that, right? For the inference, yes. Yeah, for the inference, that's where the benchmarking happens, right? Because that's where we compare with our benchmark, right? Yeah, no, for the inference, yes. Yeah, but I want you to label it, and then we'll take the doctors afterward, right? Because what we found out is that doctors, they have very, very limited time to do these things, and they just want to look at. Doesn't mean that every time is very accurate. They will so they rely on biomarkers and some other things happening in the blood test and some other stuff happening to pinpoint. No, you will have to look somewhere else. But usually just focus. They have a couple of minutes. They just look at that center volume and then they move on to the next patient.
Yeah, a buddy of mine's not confident asked about this. Look at like a retinal scan and maybe like
fundus, yes, fundus imaging, yes, and biomarkers. Yeah, this one, Charles Wyckoff is very, very, very well known nationwide with his center. When we really appreciate his time because throughout the collaboration, he would give us basically some kind of patient data, and then they have some labels, and then we just run our own, discovery algorithms. We're basically kind of figure out what's really happening that doctors never labeled. And he was very amazed. And that's why we fished him into collaborating because he missed stuff. I mean, his team missed stuff that the AI figured out. And that's where we like, this is very, very interesting. So like a discovery algorithms. I mean, still we are barely scratching the surface in this, barely.
Yeah. Do we have any examples of patients that don't have anything? Seems like all of the examples.
All of the data, they have a disease in some levels. Yes.
Okay.
Yeah.
We're not, if we find another data set of people without it.
Oh yeah, if you want to add it to there, as far as very fair addition, basically, yeah, absolutely, yes. And there are some out there, yes, but in this data set, no, we don't have any patient like that. Okay. Performance metric, we spend a lot of time in performance metric classification and regression, so you just want to be careful about that. We just discussed this about the project. Take an imbalanced data and then just run it as it is, then you just classify everything as the most dominant class. And oh, I have a question. Okay. Oh, it will. Absolutely. Yes, it will. That will be a problem. Yes. Yeah, I mean, I would, so that will, so when you have, so that will cause the problem for the class entropy to start with, right? Not necessarily for the frequency, right? Is that what you are looking for, right? So the loss function itself, not how you deal with the frequency, is a problem, right? In that case, yeah. So basically, you have to change. I think you have to look at different. Yeah, you have to look at different ones. But I would between these two, I would have more trust in that case with the focal loss. I think more than the other one. If I think that would be still you have this probability, right? Right, that will be an issue still. But I think with this will be a little bit because you don't rely on the frequency in that case. Does that answer the question? Yeah. We did this in many different scenarios, and there are some very famous papers about the focal loss. They tried very different simple two examples, and these really work very well. The focal loss, it's very handy. Yes. Oh, those were basically you really pre-calculate them, right? For each class, yes.
So let's say I have my I have
Because okay. Oh no. The gamma in here is a hyperparameter. The gamma in here, yes. No, these are separate things. These are separate techniques, right? So either this or that. Yeah. Yeah, exactly. You train them for different ones, like at every epoch, right? Yeah. You just have the whole data set and then go back. Exactly. Yes, and then have different seeds every run, right? Like 3, 4, 5 different seeds. So, yeah. People really experiment, and that's different, where they change the learning rate as you train. Basically, meaning you start with really kind of have high learning rate, and then you slow it down as you go. But you have to observe basically what's really happening. But yeah, you can change in the middle the learning rate. But it's common among those who are really have dealing with the, like, ResNet 101, like a very deep network, for example. It's common. Is common. But the focal loss in here, this gamma in here, this parameter, you will experiment. So the way you do it, you will really literally generate these curves, right? And you start to say, among all of these, basically, which ones I'm most basically kind of interested in, right? Will give you the best performance, right? That's what you are looking at. These are very clean, curves. They usually don't have them this clean, but you will have something like even the seismic data. One of my former students finished up his PhD like 3 years ago. He one of the first people who did segmentation for subsurface volumes with noise, and even with such a very noisy data, very imbalanced segmentation task. He got very neat, basically, kind of curves for the gamma, and then he just okay for when you have these features in your data, then gamma should be between this value and this value. That's kind of his conclusion, right? It necessarily, I mean, people came after him and say, okay, the condition he had about what the features are in the data, they have to be updated. People looked in this in much more depth. So those updated there. But even for that data, actually, we were surprised. It gave us really very neat curves to choose from. But this is where babysitting happening, right? I mean, you just have to really kind of figure out different gammas and see what's happening. Yeah. I used to do that when my kids were young. Anyway. Okay. Oh yeah, debugging. I mean, I'm very sure all of you are experts with this by now. Debugging. So usually, and I saw some people really kind of, you know, we have different skills about debugging, but I think is one of the most important skills that anybody dealing with programming has to have is debug. How to debug effectively, right? Because you know you are inside that box, you're reading your own codes 200 times, right? It doesn't matter how 5 more times will not make a difference, right? That's where visualization techniques can be very, very important. That's where one of my former students, Charlie, he used to have this kind of built his own interface, kind of has a big screen, TV screen in the lab, where he's monitoring every single thing happening, the gradients, the activation functions, everything that's happening in there in the training has an idea. And then as soon as he starts to see a pattern, he's okay, now there's something that's exactly happening at this data sample at this point. And then that's where basically he pinpoint exactly where the problem is and he gonna fix it. And there are many tools on GitHub. I mean, many tools. I find it, at least from my students' experience, they create their own debugging tools. It's much easier than using somebody else's debugging tool. But you know, if you use machine learning for the future, I think it will be very, very handy just to have your hands on, you know, some of these debugging tools that are out there in the GitHub and just start from there to build your own. And there are many, but visualization techniques are really extremely important. So these are the things that we looked through in throughout the semester. When we have capacity, Jinsong, she's out of town, but I wish because that's her thesis. What is a model capacity? How you define model capacity? How you can calculate model capacity, like from a theoretical point of view as well as from experimentation. If you have a low model capacity, it means basically the model doesn't really have enough degrees of freedom to handle how much complex data is, right? That's what model capacity is. That's what low model capacity is. Now, can you increase it? So now you have to increase, either you increase the number of filters in each layer or you increase the number of layers. So you have all these different, basically, tactics to do, right? On the other hand, when you have higher model capacity, and we looked at those cases basically where the model is really an overkill to your data. Like the data is very, very simple. The model is much deeper than what the data requires, and that basically becomes a problem, right? So because basically an overfitting can be a problem in this case. So you have to simplify your model in that scenario. And this is something that I think for people in the project, when you use a pre-trained model, just be careful what pre-trained model you are using because it can be an overkill and overfitting could really happen in that case. Too few data. I mean, that's always the case when you talk with anybody says, no, you don't have enough data. Not necessarily data as a data, but annotated data with annotation if you're using fully supervised. So people really use things like augmentation, right? And augmentation, for example, this is a very, very common technique. You can see them basically that are, data loaders that already have augmentation built in them. You have this original image, and then you start basically do rotation, flip, add some noise, blur, some vertical flip, some crop, different classes, different zoom in, zoom out on the object. But these things work like for a computer vision problem is very easy. They work, right? But if you go to something like medical data, right? The medical data, can you play with that? I mean, you have to be very careful to do these things, right? Because if you take the subsurface, for example, the geophysics one, you cannot flip it upside down. That will change completely the whole meaning of the geophysics phenomena, right? It's upside down. It cannot be done. Same thing for the retina and the CT scans, X-rays. flip them upside down. That will not really help, right? It will confuse the algorithm. So people have added a lot of, this noise here, noise and blur, as kind of a way to augment. And I have seen people do much more than that. Like these are what we refer to as like photometric. You just change the value of the single sample. It can be in the speech as well, like you add Gaussian, like an additive Gaussian. But also people really change things by removing samples. Like I was talking about super resolution, stuff like that. Like in a speech signal, you remove some samples, right? Make it much more noisy that way, right? Removing some samples. Yes. Yeah, so we usually it happens in random. You pick which layer, and then just in each feed forward iteration, then randomly it will pick some neurons to make the output zero. Yeah, yeah. Basically, as if you already multiply that neuron output with a zero. That's, you just keep it zero because it will be input to the next one, right? So it will be a zero, so it didn't really impact anything in the going forward, right? But it has to do it randomly because if you zero the same neuron every single time, then what's the point? Yeah, exactly. So, but it's random for that layer. Okay, transfer learning. We'll talk more in detail about this later on. But here is especially for those who are really doing the project, and you are doing this in the homework a little bit. So you have your ImageNet data, you have AlexNet, people train this on it. You don't have to worry about training it again. But now you want to apply this to some other data, like something like that, right? So now you take the AlexNet, you freeze. You see the box in here, the gray box, right? You see this one, C1 here. You take this one, you freeze it. And now you just have the fully connected layers, the last 3 layers. And then now you retrain this. While you are training this, basically, what freezing means when you are back propagating, you are not updating any of these weights. That's what freezing means, right? So you don't really, you do the whole thing. You do the forward propagation, back propagation, you do the whole thing, but now you don't update these weights, right? You keep them as they are, these weights in here. You only update the last, which is the fine tuning, right? So we call it fine tuning in this case. Some people do it for the final layer, some people do it for the last 3 layers. For AlexNet, it depends on what you want to get out from your application. But this is very, very common. You're already doing this in the homework anyway. So, but we'll look at this in more detail when we talk about active learning. Visualization. Looking at the gradients, I'm very, very big fan of basically the gradients are extremely important to look at because they are the true description of what's really happening in the neural network. I mean, this has been our research for the last 7 years, that people look at the activation function, but when you look at the gradient themselves exactly as they are. If you have to be careful also how you visualize them, and then hopefully Mohit will talk about how you can do that in explainability. Then it will give you quite a bit of really an X-ray of what's happening in the model at the neuron level. Okay, yeah, this is the histogram. I'm just gonna move on. We did this. Okay, so let me go through the exam. What do you mean? In performance? Or for the exam? Oh, they did better than you. Yes. You asked about the exam, right? Overall, you ask better questions. So let's put it that way. So let me give these out. Just if you have a couple of minutes to give them. My damn glasses. So this is L through Z, L through Z, Larry through Z. Last name. And this is A through K. Sorry, we'll make you busy. A through K. A through K, L through Z. Last name. And there will be mistakes. Sorry for that. Don't take somebody else's paper. Leave it back, please. Take only your exam paper. Should we keep it busy around you? What? Oh, can you look here?
Yeah.
Sorry. I mixed them up, so. Oh, wow, that was easy. Okay, if I can get your attention, please. Or maybe not, or maybe not. What about now? Can I get your attention? Oh, here are the averages and the standard deviation among the different sections. So the average is very, very close to each other between the three sections, like around 65 plus or minus. The graduate section is the standard deviation is really high because really the lowest and the highest people are in the graduate section, which is very interesting. So the lowest couple of students and the highest number of students are in the graduate course, the graduate section. So that's why we have a little bit high standard deviation. But the ranking curve is not bad. I mean, I look at it, it's very, very decent actually. Yeah, yeah. Can I get your attention, Sammy? Okay. Yeah, if you look at it is linear, which is yeah, I have usually there is a drop at the bottom here, but there is no drop, so I think that's a good sign. So now you have 1 week until Monday. If you really feel very strongly about regrading a question, please submit this as a Piazza post, as a private message to me and the TAs, the instructors, by Monday of next week. So if you really feel that you deserve more points on a certain question, so please post that. Include like a copy and image of that page and why you think you need more points, right? So please do that. Solutions. I will only go through the solutions now, so I will not share the PDF. So the slides have the true and false solutions. So you don't have to go through this. You have them on Canvas. So let me go to the PDF where I really need your focus. I get surprises in the second question. I thought people will do much better than what they did in the second multiple choice question because I think it was easier than but question 4, I knew people will not everybody will get that. But question 2, I will expect everybody to really get this. So this is for the learning rate. And this is for everything is fixed, right? So you can go from alpha 1, alpha 2 is a little bit higher, alpha 3 is definitely much higher, and alpha 4 is meaningless, right? It's very, very, very high, right? So the second choice is the solution, right? So is the choice. Part B, basically you have this data now. You have really 5 folds, right? You have 5 folds, but you have 2 of them in an error. So the output is basically 2/5. That's the error, right? So it's really 2/5. That's really the error in this case. Right? Why? Because the top 2 will always be the error, right? You see the top 2? You see those? Because the nearest neighbor, right? So this will always be the error. You see that? That's where the 2/5. So this is 5 folds, right? And these 2 will always have, if you have the nearest neighbor, right? You will have, this is comparing this with the other ones, it will pick this one as the error. If you pick this one, it will be this one, right? So you have two errors. So 2 out of 5. Okay, so 2 out of 5 will be the solution here. Okay, ridge regression. I thought this is straightforward. I think everybody got this, so I don't think it's a problem here. This one here, when you really increase, the size, then basically because this is what really ridge regression is about. On average, you're really moving away, right? So on average, you're moving away. So that's basically the part. The third choice is the correct choice in this case. Okay. They're squaring, right? This one. But because they are squaring, right? So I think the difference they are squaring, so it goes away, right? So it's larger because you are looking at the absolute value, right? If you are taking plus and minus, not absolute value, then yes, it will not inflate. Okay, this one here, basically you have what do we have? We have 5 feature, right? Yeah, we have dimension of 5. We have 4 clusters, right? So basically now right away you have the centers, the mu. You have 4 times 5 of them, right? How many covariances? Also, we have 4 times 5 of these. And how many probabilities? Yes, you have 4, but you need to update only what? 3 of them. The fourth one you can calculate. So it's really 4 minus 1. So the exact number is 43. But I was kind enough to give you a range. So even if you make such small mistakes, you should get this answer correct, even within those numbers. We did this in the lecture. This is tangent, yes. What do you mean the whole matrix? The what? Yeah, but I'm saying it's diagonal covariance in here. So we'll have all of them will have the same dimension, right? If I use a different type of covariance shape, then that's the tricky part, right? Then you will use this amount above 50, right? Okay, we did this tangent. Drop out. Yeah, I think everybody got this. Almost everybody. Drop out. This one here, I think very few students got this wrong. But when you look at a convolutional layer, then the number of biases equal to the number of filters. That's really true because you have just one bias for each one of them. The number of weights depend on the depth of the input volume, right? Yeah, this one here, I was a little bit surprised that some got this wrong because this is what I was talking about stress testing. If you look at the output from this one, it always will be above 0.5. It doesn't matter what the input is, will always be a cat, right? So this is really the answer is all cats in this case. Okay, this one here, I think almost most people get this. I mean, if not everybody, increasing the batch size, or what you're doing in here, you're not really changing much about the overall performance. You're really changing how it get to the solution, right? And we look at these curves in a different fashion, but all of them basically kind of lead to the batch size as really the parameter that you are really dealing with. This one, I think here everybody got this correct. It's very simple calculation for the pi and the mu values. Some people really missed to divide by 3, so they lost 1 or 2 points. But overall, this is the solution for this problem. This one here, I think everybody got this right. If you answered any of these, then you get the full mark. I don't think there is any third answer. Yes.
Is there any difference?
No. It's a syntax.
Okay,
Yeah. So let me ask you this: how many of you use ChatGPT during the exam? No, but some people used it. Oh, my students, the TAs.
Oh, there's one there.
Yeah. Oh, it's a lot. I wanted you to do an experiment to see how bad did you. So for those who used it, do you believe in it now?
It's not like
Oh, not yet. Yeah, you have to be very careful. Yeah, and I was surprised that some people really use it because it takes you at least 30 seconds to type in the whole question. By that time, I like true and false, I counted 30 seconds to each one of them, right? If you type that in, that's 20 seconds or 30 seconds. And so you already lost, good time. So yeah, just be careful about these online tools. When my students told me, basically, I said, great, I want them to learn and listen. Don't trust it yet, right? Not yet. Please. You are a little bit higher than those who read the news articles. Okay, this one I think is I like this problem very much. Okay. So you have your data, right? You have basically these loss functions, right? L1, L2, L3. The first thing you notice, look at this one, you have absolute value. This one you have square. And then here you have this kind of very strange omega 0, right? But now when you are optimizing this, you are minimizing this, what will happen? Remember, this is a huge number, right? So this means we'll make omega 0 equal to what? A 0 right away. So this right away is L2, right? So this is L2, right? This is L2. That's how you start. Basically, you put just as L2 in here. And then now between these two in here, since we have the square, right? This is something like the square in here. That means it will be biased by the outliers, right? So we're the outliers. These are the outliers, right? So the one that will shift to the outliers will be the one with the square. So this one should be your L1, and then you are left with L3. So that's what's happening there. But I think what really kind of I thought this one really they give out the answer, but still not many, but I think at least half the class missed this question. More than half in here. I was looking at you start from here, and then the outliers will tell you the difference between the square and this one. Okay. This one, I think nobody answered this. And my daughter, I used her name, so she really hates that nobody answered this. What you are looking at, you are really looking at adversarial, like you are really trying to create an image that will really help you to trick the model, right? So now what you are looking at, you are looking at two optimization happening. One, you want it really to look like you want to minimize basically the difference between your model and the y hat at the start. At the same time, you want to minimize basically the difference between the data and the X no park data, the no park data. You are optimizing between these two. Of course, you will have basically, even if you miss these multipliers in here, you get the full mark. But I think many people really spend quite a bit of time to change this one. All what you need just to add another term, which is this one. And that's basically how it looks very simple, but really works. It will give you an image that really tricks basically the model into thinking this is a no park. And that's how we generate adversarial examples in here. I'm hoping to add this to the homework 7 to see it is basically working in front of you. But this is really the solution for it in here. It's simpler than what you expected probably. What else? Yeah, this one here, I was surprised. I thought this one just straightforward. We have the formula in the slides, right? But I don't know. So you have 128 times 3, and then you have 0 weights and biases. And now we have that formula, right? We have the input, right? Filter size, padding, 2 times the padding, and then we have that formula in the lecture side, right? If you just enter those, you will get 120 by 120, and then why 32? Because you have 32 of these kernels or filters, right? And the same thing in here. What is really the dimension? For each one of those filters, you have 9 by 9 by 3 because the input is 3, right? Because the 3 is channels in here, plus the bias, right? For each filter, we have 1 bias. And then basically you multiply by the number of filters that you have in. Either you give this formula or you give this number, it's accurate. For the pooling, basically the pooling, I think I found out many students don't understand what pooling is. Because pooling, you are not really doing any linear combination or anything. You are not processing. In pooling, you are just picking basically your data samples, right? So definitely you have 0 in here, right? So this is 0. There is nothing here about, there is no weights, there is no biases in the pooling stage. We are not doing any processing in here. You are just basically, you are reducing the dimension of your data. That's all what you're doing. You are really downsampling. That's what I'm doing in pooling, right? So if you're doing pooling by 2, that basically you are picking every other sample in each dimension, right? So basically 120 becomes 60, and then 120 becomes 60, and the 32 is as 32. You're not changing the number of channels in that case. And you keep going with that, basically the same thing. The fully connected layers, just we have 3 activation maps in here, and then 3 times whatever the size of the input in here that we have, plus the bias that we have. Anyway, so this is the solution for this part. Softmax, I think everybody got this correct. Softmax multiplication, and this one here also, everybody got this correct. Either you said 1/3 or 1/3 or 0.33. I think almost everybody got this one here correct. This one here. You don't really need to plug in any numbers in here to solve it. This one here is, I think also many got this, if not almost 90% of the students. Yes. Yeah, you get 1.33 for each one of them, 1/3, right? Oh yeah, you will have basically there's an error happening in here. Not an error, basically you will get a solution. You'll pick the first one, but may not be accurate. Yeah, it will be the first one. But it's not necessarily that's the ground truth. Right? This one, this is scalar. I saw a couple of people doing this as a matrix. This is very simple, just a scalar. And then the part B, this is normal equations, right? In part B, basically, that's where you have the 2-dimension. So now you have a 2x2 matrix in here. And it's either you do it this way, you simplify it to this one, then it's very obvious. Only when you have lambda equal to 0, then the theta hat will be equal to theta 1, theta 2 in this case. But that's about it. Any questions about the exam? Yes. Can you please take a picture of it? Just send as a private message on Piazza, and yeah, okay. Yeah, please do the same. Okay. Yes.
So we had to write down their second time versus one, or is that the question to ask?
No, he said basically he got exactly the same answer, but
So the answer above that is.
that's what. Oh, but you have to simplify it. Yeah, you have to simplify. You have to simplify. Yes. Add 3 points. Not bad. You have to simplify it. Yes.
I think that the first one simplified already though, because they're not really getting rid of any coefficients. So I feel like top one is at the bottom because all you're doing is doing the
Okay, you should be a patent officer. Okay, post it, please. Okay, thank you. I told you if you feel strongly about something, just post it. Send me a Piazza message. Okay. Any questions? So please, I want to reiterate this. You have until next Monday, for regraded quiz. After Monday next week, then the exam grade is final. Okay. See you Wednesday. Thank you.